Hello and welcome to Excode 2025. This year, we bring a new and improved curriculum with a revised teaching material. We also will have amazing speakers such as from Google, Meta, HSBC, and the head of Tech Southwest. And finally, we also have an improved structures with amazing workshop leaders that will volunteer their time to help you learn to code. But all of this while keeping the things that you love and enjoy about Excode. It's entirely free, 1. 2, it's certified. You get a certificate at the end, you can put it on your CV, LinkedIn, and more. It's for everyone. Regardless of your level, we take it where you need and we bring it up. And then it's also professional. Just today, we've been shortlisted as one of the best education initiatives in the Southwest. We won several other awards in the past. So, what it is? It's free. It's certified. It's for everyone. It's professional. What it is? It's free. It's certified. It's for everyone. It's professional. That's the quote from Steve Jobs. Hope you get it. That was the idea. So let's get started. And my question to you is, are you ready? Virtually. Yeah? All good. That's great. Let's get started now. That's a coder. That's how a lot of people see the idea of a developer. Kind of be the nerd type of person, maybe always like mad scientist type of person, or maybe something like this. Or you got kind of Mr. Beast's new video, I spent 24 hours bird with a developer. And these are, unfortunately, with all of these prejudices that a lot of people have around developers, coders, programmers. And this is due to several reasons. But here at Excode, we're here to show you that those are actually false, and that coding can be made fun. Well, maybe not this type of fun, more something like this, but coding can be fun and engaging and interactive. And coding can also be extremely beautiful, because code is per se an activity that, and you will realize, shows really a lot of inherent beauty when you see and you solve a complex problem, when you see long lines of code that actually make something happen in the real world, or when you see a positive impact of your creation. And then coding is also immensely powerful. Powerful because if you look at all these applications, they were made thanks to coding. And coding is powering a lot of our society. Obviously, I'd be a bit surprised if you're able to code any of this in 7 weeks, but you can try. But the idea here is that we want to show you these 3 ideas: fun, powerful, beautiful, while showing you how coding made all of these things possible. Because coding, it is a superpower, and it shouldn't be gate-kept, and we're here to bring it to the masses. So, you can be asking, Lorenzo, thank you for the marketing pitch here, but what is Excode actually all about? Well, let's start with the what. It's about an art and science of computer programming. Art and science. Well, the science side is a bit simpler. It's computer science. It's because there are some math, there's some reasoning behind that, although no prior knowledge is assumed. But the art side is really important as well. Because when you look at programming, it's not only about the syntax or the lines of code, but it's about a way of approaching problems, of looking at them, of finding solutions out of complex situations, of analyzing an algorithmic and analytical way, as written here, of approaching problems. And this, along other things, is what makes the developer mindset. The developer mindset is extremely important. This is what we're going to try to share with you in these lectures. Then it's also around how to understand and use computers that are omnipresent in our society to automate tasks, to get better grades, to get jobs and other advantages. And finally, we're also going to teach you Python, which is one of the most versatile and best programming language, and focusing both on the tools, really important. We're going to use Google Colab as well and other relevant tools in programming, but most fundamentally, the concepts. Because in 5, 10, 20 years, the tools may change, but the concept, the way you approach problems, the way you approach code, will remain fundamental for everyone to know. In this concept, the idea is that you can apply it regardless of your discipline, regardless of the topic, to find solutions to problems, to use it to automate tasks. So, what? Now the how. How? It's structurally 30 minutes of lecture, then 5 or 10 minutes of case studies, usually with a speaker, and finally 45 minutes of workshop, where you will have workshop leaders, and either in person in the auditorium or online. Online will be live streamed on Teams and also available as recordings afterwards. We're also going to have the concept first. So in the lecture, I will be your lecturer, Lorenzo. Nice to meet you all. And I will cover the concepts from a really ground-up approach. So starting with analogies. We're going to try and have a bit of games here, having someone from the audience come. We're going to do things such as magic tricks, play with props and others. So really give you real-world analogies of things you really understand from the word. And then compare that and draw comparison with the programming concepts. So that then you can bring those real-world concepts to the programming realm and apply those there and see the similarities or the differences using diagrams, then pseudocodes, so really simple code, and then finally in Python through your workshops and the hands-on part of the Excode experience. We're going to also have fun, and that is the most important thing. Because what I hope to give you along these weeks is really the idea of sharing the passion. And that is the idea, is we're all here, the team and the workshop leaders, passionate about programming, and we really want you to take that. If there's one thing you have to take out of this part, is really the passion, the interest, the engaging, the power that coding is, and take that with you. That is our goal. So that is how we're going to teach you. Then, why me? So my name is Lorenzo. I've been teaching Excode last year and teaching programming in several situations, such as through my blog and through other ways. I also deliver talks and work in AI right now. I have a various wealth of experience in various parts of programming, both app development, web development, some Arduino, and now, as I say, specializing in AI, where there is a lot of Python. I also have worked on several ventures and projects around coding in several various topics. If you want, even virtually, you can just follow me on LinkedIn. That's much appreciated. Just this way we can connect, and then I'll share some things about the course as well and future Excode opportunities that will be in term 2. So let's look at the code structure now. So it is in 7 weeks. We are currently in week 1. So it is starting in October and then continuing with 2 other weeks. We're going to do a pause in reading week, and then we're going to have week 4 and 5. Week 6 is going to be exam week, so there's going to be no lecture, and it's asynchronous, so the attendance is not required. And finally, week 7 is a celebration week, where we will have several speakers. We'll also have the head of Tech Southwest, and we're going to give you certificates, photographer, and other things, kind of celebrating, and also trip to be won for the Google London office. One thing I'd like to say about the exam. The exam is extremely simple. We're assuming that everyone will probably pass that exam, and the idea is that you have unlimited retries and it is a multiple choice question. The goal of the exam is not to assess that much, it's more to have a formality for you to actually say, I've done the course and pass the exam and then get the certificate. So if you follow the classes, you'll have no problem with the exam. Regarding now the question that everyone's been asking, and maybe why you're here. How do I get my certificate? It's quite simple. You need to attend 4 out of the 6 classes, plus do the really simple exam. 4 out of 6 classes, exam week is automatically counted as attendance. So realistically, you need 3 out of those initial 5 to get your certificate in week 7. And then you can get this really nice Excode certificate. Now I'd like to give you a demo of the platform to show you how it works. I'm going to step out of screen and you can still hear my voice while I'll show you the demo. This is the Excode dashboard. You all have received access through your email. And once you log in, you can see your name, edit it if you need to, as your name will be in your certificate. And then every week, you can see the material for that week. The way it works is at 8 a.m. on Monday, the material is shown to you, and the solutions are shown at 9 p.m. on Tuesday, just after the workshop. On the platform, you can see some important information, such as the workshop informations, your room, or if online, simply the fact that you are online, plus also have the FAQ, which is really important, because if you have any question, please first always check those before asking us, as we are a bit at capacity currently. We'll also be able to find recording, such as this one, starting 2 days after the actual sessions on Tuesday, so the recording on Thursday. And finally, also access the slide deck and the lecture code, workshop code, and workshop solution. You can also check in for each week. So you put a code here that you will receive at the end of the slide deck and the end of the lecture, and then mark as completed. Once you've done so, you will have a check-in system where you put a rating. You move these from 1 to 5 for each one of those, and then you can also leave additional comments or feedbacks. It's important to say that we will read all of those one by one in order to prepare for the current week. So, as a recap, here I am again. Hello. So Excode helps you learn to think like a developer while having fun. And to show you that, I have actually someone from the team that will talk about my Excode experience.
Hi everyone, my name's Thalia Champ and I'm a second year computer science student here at Exeter. This time last year I was absolutely terrified to start my degree. I had no programming experience whatsoever, I hadn't done GCSE or A-level computer science, and I was feeling so scared. One day I was scrolling through the university's news site and I saw Excode being advertised, and I thought, this is perfect for me, it's free, it's a beginner's friendly course. So I signed up and I completed it, I got my certificate, and now I'm here. Thanks to Excode, I've been able to pass my programming modules with some excellent grades, and now I'm looking at applying to tech internships for my placement year. There are 3 things that I really love about Excode. The first thing is its accessibility. It's totally free and it's totally beginner friendly, and it doesn't matter whatever discipline you're in, you can take this course. So if you haven't done any programming before, that's great because this course is especially for you. The second thing is it's so easy to complete alongside your studies. There's no clashing with lectures or timetables because it's completely outside of your timetable, and you get to meet some really nice people on this course. Number 3 is opportunity. If you put this on your CV, employers will see that you've taken initiative and gone outside of something that you're studying into something extracurricular that's especially relevant right now. Once you finish this course, you'll get updates from the team about XAI, which is a machine learning course. So if you find that maybe you want to have a look at something different in terms of career path, or you find AI to be really, really interesting, then sign up for that as soon as you get the notification. I met some very, very lovely people here at Excode, including Grace, who's a history student. We were in the same workshop together and we were able to work on programming assignments together, and we found out we lived 10 minutes away from each other back home. So get to know the people around you and maybe you'll meet some very close friends. Finally, you've got some really, really great workshop leaders with you. Ask questions. I can't stress enough how important that is. Take advantage of these people because they've got a lot of knowledge in their brains. And a final piece of advice I'd give you is ask the stupid questions. So many people think of the same questions they've got milling around in their head, but they're so scared to ask these questions because they think they're going to seem silly in front of their peers, but in fact everyone else is thinking exactly the same thing. So ask the stupid questions and you'll always get an answer. So enjoy coding and thank you for listening.
Excode Week 1, the magic behind the screen. This week, we're going to cover 4 core arguments. One is what is a programming language, then what is a computer program, then Python, and finally, we're going to talk about thinking like developers or the developer mindset. So let's get started. What is a programming language? So it's easy. We got 2 things to work with, programming and language. Let's start with language. So virtual hands up if you talk a bit more than one language, more than English. Regardless, we kind of all understand what a language at its core is. The idea is that I want to communicate information. It's the idea of communication. So right now, I am talking, and while I'm talking to you, I am communicating information, things, knowledge, and the related. Quite simple. However, as some of us would like to forget, there's also the programming side of it. And this is where it gets a bit different. when I'm talking to you now, if I do a typo or something, or do a mistake, or do an English mistake because of my accent, you'll still be able to recognize what I'm trying to say. With a computer, when it's programming, the rules have to be much more strict because of the way computers understand information. By that, it means that we have a syntax in which regulates the way we communicate information, the instructions we want to give to the computer. But now, you're lucky, because in 2025, we've got plenty of tools to make that side less and less relevant, which means that nowadays, syntax is a much lower part of programming, thanks to AI, Google, the workshop readers, online assistant, and more, which means that you can focus on the art aspect, which is the reasoning aspect, the higher level. And to recap, the idea of a programming language is to communicate information to a computer, and we have to do so through a syntax that communicates instruction clearly. So that's a bit how it works. Got a human here. The human is writing some code, like print hello world, and the computer will display hello world on the screen. So this is a sample, like the initial line of code. And you can see, first of all, we usually have the line in order to have those in order. Most programming language will read code in order, so character by character, line by line. We have our first line here, and we have an instruction. The instruction is print. Here we are communicating to the computer, print something, display something on the screen. What do we want to display? The text, which we can call string, hello world. We have some syntactical element here, such as the brackets and others, which we will see in the current and following weeks. But as its core here, we are asking the computer to do something for us, printing hello world. And printing is extremely important in plenty of places in programming. We can, for instance, after running a test, print test succeeded or test failed, or we can print the amount of time we do something, or print other information. So this is one of the core and initial things in programming. Then we also have comments, usually represented by an hashtag, and the hashtag in the comment will kind of tell the computer, ignore everything that is after that. And the comments are for us developers to remember what things does. There is the quote, when I wrote this code, only God and I knew what it meant. Now only God knows. So comment definitely helped for it. And then there's also all the aspect of errors and debugging. As we say in programming, if you write code differently, we will re-register that as an error. So let's go and let's look at some code. So this is taken from the lecture code. You can find it on your platform here. All of our lecture code and workshop code is done on Colab. Well, Colab is an amazing tool. You don't have to download anything. It's entirely free. And you just go here, go what is a programming language. You can read this in your own time. Then you can see the first line of code. So here we see print hello. Once you do the workshop, like this is the workshop, you don't have to change anything. You can literally just go here and write the code into those boxes. You don't have to change anything about the structure. The same thing here about the lecture. You can see here the code is already written, print hello. And when I click here, it's going to play it, to run it. Running it means giving the information, passing it on to the computer. So if I click here, print, apologize. I'm just going to show the output. So when I click print, the output is going to be hello. And you can see here this composition of it. As you can see in other programming languages, such as JavaScript or Java, it is going to be quite similar. This is the same thing as saying in human languages, I can convey the same information in English, Italian, French, ciao, bonjour, hola, and others. But the idea is that the syntax, the way these are written, is different. You can also see, if I scroll a bit up, that Python with the print is one of the simplest and closest to English there is. After that, we can also see some example of comments. If I run this, for instance, it will do nothing because everything that is after the hashtag is considered as a comment and ignored. If I do this, it's only going to print test because print test is run by the computer, but what is after the hashtag is ignored. And this, if I run this is some code, just some English, it's going to give an error, invalid syntax error. Why is that? Because it is not recognizing this as Python, and thus it recognizes as an error. These are all examples of possible errors. As you can see, Python is also case sensitive, which means that a capital P is not the same as a lowercase p, and thus will bring an error, if I have space before, or if I do a typo, or if I don't follow the syntax, these are all going to result in computer errors. That is why the syntax is more strict. But once you get that, the conceptually, it is not that complex. So we just covered point 1. Let's go with point 2. What is a computer program? And you can see here we have a human and a computer. And they are communicating information. So most often when you program, the idea is you give instruction or a set of instruction. And a computer program, it is a set of instruction given to a computer. Here, for instance, you can see we're asking to convert temperature from Celsius to Fahrenheit. And what is often really helpful in these situations is to think at it as input, processing, and output. And usually these type of diagrams are great. You can see the input is the temperature in Celsius, the processing is multiplying and add 32, and the output is the temperature in Fahrenheit. By conceptualizing programs this way, we can clearly see how the set of instructions work and what happens behind. Another example here is a program to send a mobile notification upon receiving an email. The input is the email, so we get the email body, the email subject, we process it, now we don't care what it is there, and then the output, we have that as a notification. So on your phone, you see the subject and the start of the body. Another example is something to move a robot. The input is the robot in its environment. The processing is maybe looking at the motors, looking at what works, what's around, doing calculations. And then finally, the output is the robot actually moving. So it's a movement, the motors moving. And then you get that. So that is the idea of a computer program. And we can take that a bit also from life, where more often than not in life, you have a goal, that's your output, that's your intended outcome. Then you have a present situation, an environment, that's your input. These are all the things that you get around you. And then you got the processing. These are the steps that I need to take in order to reach my output from the input. And after that, we can look at Python. So Python is one of the most versatile programming language. It was released around the 90s, but it is still extremely relevant. It is in fact the most used today and one of the simplest to learn, which is why we decided to go with Python for this course. We're gonna try to teach you the best way possible. So the last point of today is thinking like developers. What does it mean? Often we have a bit of a categorization here. Coder, maybe someone that just write code, write the syntax, and that's it. Programmer, high level, someone that writes software, so complex code with a lot of components and parts. Developer is even at a higher level. The developer communicates as well. He understands the client, he understands the needs, which means that when you have an app to create, if you have a really good project idea, and then you want to create the software for it, look at a higher level first. What do I need to create? What is the best platform to use? What is the best language? Python is one, there are plenty. What is the best systems, tools for me to use in this specific situation? Then apply your concept, your knowledge of the programming concepts to that. And then finally also supervise the project and then also do the lower things, such as actually writing the code, writing each component, but then testing it, making sure it works under various situations. And that's why with Excode, we're going to try to turn you into developers. And now, to finish this session, I'd like to invite a guest speaker, Finn Harris. Finn was the youngest student teacher in the country and will speak about the science of and evolution of learning. Thank you.
In 1970, a small machine entered classrooms and nearly broke education. The handheld calculator. Some schools banned them completely. The fear was simple, that students wouldn't learn maths anymore. In the short term, it seemed to be true. Some students with calculators breezed through core maths work, and exams hadn't fully caught up yet. However, education evolved. Exams split into calculator and non-calculator papers, but the real change was in the teaching. A shift away from repetition and towards concepts like algebra, trigonometry, and modelling. The calculator didn't kill maths, it reshaped it. The routine work fell away and it pulled students up into a higher order of thinking where the calculator became a tool, not a crutch. And the bar rose. Anyone who's taken a physics paper will agree. In order to succeed, you must grasp the concepts, because without that, a calculator is useless. In the mid-1990s, the internet hit mainstream. Panic followed. The end of research. Students will just copy, media said. And at first, the fear seemed real. Some students could print pages from Encarta or the early web and hand them in as polished homework. But once again, the system evolved. Yes, plagiarism checkers closed the obvious loopholes, but the real shift was in what counted as learning. Mark schemes began rewarding for synthesis, comparison, and critical analysis. The internet became less about finding answers and more about constructing understanding. The internet didn't kill research, it forced it to mature. Today, research is faster, broader, and more complex than ever. And once again, the bar rose. Students must now sift truth from noise, evaluate sources, and build arguments, because without these skills, poor work is obvious. The panic is familiar. The end of thinking. Students will just become lazy. Right now, I admit, the concern seems valid. Some students hand in generic AI answers that on the surface may even look polished. Standards are wobbling. However, if history is to be any guide to us at all, it will tell us that education will not stay in the panic stage. New tools don't sit outside of learning for long. They fold in. The same way that the calculator became a part of maths and the internet became part of research, AI will also likely become part of how we learn. And when that happens, the focus of learning will shift. AI won't kill thinking, it will reframe it. Less time spent on the surface work and more time spent on what sits above it, connecting ideas, asking better questions, transferring knowledge into new problems. Tools don't erase skills, they reallocate effort. Fast forward 10 years in time. In a hypothetical world, if everyone uses AI, the difference won't be who uses it, but who uses it well. Poor, weak, and lazy AI work will stand out immediately. The demand won't be for producing content. Anyone will be able to do that. The demand will be for proving what makes you different. AI raises the floor, but only you can raise the ceiling. Which is why this year at Excode, we are offering every student a full year's access of Google Gemini Pro, a tool that levels the field, but not your ambition. AI won't take away your creativity, your curiosity, or your courage. It will test them. Anyone can use a tool, but the best will transform with the tool. So the question isn't, what will AI take from us? The question is, what will we take from AI? Which is what I believe to be a chance to think deeper and reach further than ever before. Thank you very much.
Thank you, Finn, for the amazing speech. And now, to close this session, I'd like to give a couple of thank yous. First of all, to the amazing Excode team that made this event possible. Then also to all the workshop leaders that are volunteering their time to help you learn to code from various disciplines. And also to the sponsors of this course, such as Google and the University Alumni Fund. Additionally, I'd also like to thank all the societies that helped in marketing and running this course, along with the various other organizations that helped doing so. To close this session, I'd like to give a quick recap. So this week, we've seen what is a programming language, a way for us to communicate instruction to a computer. We've seen what is a computer program, a set of instructions that make certain inputs, that do some processing, and that gives an intended output in order to do and achieve a goal. And then finally, we also looked at Python, which is one of the most versatile and easiest to use programming language, with the print command allowing to print something on the screen, and with comments that are ignored by Python. To close off, we looked at the developer mindset, something that allows us to approach problem in a higher level view, looking at all the systemic analysis of a problem and the various components at play, such as the requirement, the outputs intended, and more, and how to make all of that works from both a client perspective and also a programming perspective. So thank you all for your time. If you'd like to check in, the session for this code is EX1PT. You can enter it on the platform, fill in the feedback, and you're checked in. And I'll see you next week. Thank you.